Hi, in section 2.1, we're talking about linear equations in one variable. Our goal here is we want to learn about equations and the meaning of solutions, solving linear equations for one variable, and then we want to do some applications of linear equations. So let's start out on this page with some definitions. An equation is a statement that two expressions are equal. Next definition. If the statement is always true for any allowable value or values of the variable or variables, then the equation is an identity. If the statement is never true, it is a contradiction. If the statement is true for some values of the variable or variables and false for others, then the equation is conditional. The set of values that make the equation true is called your solution set. Any one element of your solution set is called a solution of the equation. That's an OL, solution of the equation. And two equations that have the same solution set are equivalent. They're equivalent. We use the word equal all the time, but we will say they mean that the equations are equivalent. Okay, so let's look at an example. So here, in example 1, I solved 3 equations. I want us to identify the types of equation, and then let's talk about the solution set associated with them. So here, I gave you the equation 3x plus 5 equals 3 times the quantity x plus 3 minus 4. These are the steps we take to solve this equation. You need to make sure you pause the video, make sure you understand the step-by-step process, because I'll expect you to be able to solve the equations. Now, whenever we go through and we solve the equations, we end up with 0 equals 0. Well, that's a true statement, which means this equation, the type of equation this is an identity. This is an identity, which means any real number will work. So the solution set is all real numbers, which is denoted as this like script R, okay, or bolded R. So part B, we have this equation 3x plus 5 equals 3 times the quantity x plus 3 minus 5. When we go through and solve these equations, we end up with 0 equals negative 1. That's not a true statement. 0 and negative 1 are not the same, which means this is a false statement, and a false statement is called a contradiction. So this is a contradiction, which means the solution set is the empty set denoted as 0 with a slash through it. That means it's a set that has nothing in it. It's not the same thing as 0. 0 is an actual element. This is denoted as the empty set. Okay. Now part C. Part C says x squared equals 4. So we go through, we apply the square root to both sides. When you apply the square root, you get plus or minus that answer. We get plus or minus 2. So we only have those two values as solutions. So this is a conditional statement, and the solution set is the set consisting of -2 and 2 only. Okay, so that's example 1. Next definition, a linear equation in one variable say the variable x, is an equation that can be transformed into the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. So our linear equation in one variable has this form. And note that these equations, because the exponent on x is an understood 1, these equations are called first degree equations. Okay? So let's look at an example. I want us to go through and solve the following equation. So here we have 4x minus 3 over 2 plus 3 over 8 equals 7x plus 3 over 4. Now, to eliminate all of the fractions, we have to multiply both sides of the equation by the least common denominator between 2, 4, and 8. So let's make that note. So to eliminate all fractions, multiply both sides of the equation by the least common divisor between 2, 4, and 8. And in red, I'm going to write which is 8. Okay? So we're going to multiply both sides of the equation by 8. So we'll have 8 times the quantity, 4x minus 3 over 2, plus 8 times 3 over 8 equals 8 times 7x plus 3 over 4. Now, 2 goes into 8 4 times, so we can really think of this as 8 over 1 if you would like to. If that makes it easier for you to see, you can think of it that way. And then we have the 8's cancel out. 4 goes into 8 twice, so that leaves us with 4 times the quantity 4x minus 3 plus, here, remember the 8's canceled out, so this is really a 1 here. So plus 1 times 3 equals 2 times the quantity 7x plus 3. And now we just go ahead, we distribute, we distribute the 4 here, distribute the 1, or just multiply these two and then distribute the 2. That gives us 16x, because 4 times 4x is 16x, minus 4 times 3, which is 12, plus 3, because 1 times 3 is 3. That's going to be equal to 2 times 7x is 14x, plus 2 times 3, which is 6. So now we simplify. 16x minus 12 plus 3 is minus 9 equals 14x plus 6. We want to solve for x, so we're going to subtract 14x from both sides. That gives us 2x minus 9 equals 6. And so we're going to add 9 to both sides. That gives us 2x equals 15. And so that's an aside. So now we have 2x equals 15. Then we're going to divide both sides by 2. So we get x is equal to 15 over 2. That's our final answer. Okay? Now you can also solve linear equations that have absolute values with them. So we need to know what it means. The absolute value of ax plus b equals c means ax plus b equals c, or -1 times ax plus b equals c. Whenever you have absolute value equations, it's important for you to check your answers because you may get a solution that does not solve the original equation. And a solution that does not solve the original equation is called an extraneous solution. So in other words, you get an extra solution. So it may not work. So it's important for you to check your answers. Okay? So let's look at an example of an absolute value equation. We're going to solve the absolute value equation, the absolute value of 3x minus 2 equals 5. So using our definition, or using our fact that we have for absolute values, this means 3x minus 2 equals 5, or we have -1 times the quantity 3x minus 2 equals 5. That's application of the fact from the previous page. Now we go through and we solve. So this means we add 2 to both sides. We get 3x equals 7. Now we divide both sides by 3 to get x equals 7/3. Okay? Here, in this one, we have -1 times the quantity 3x minus 2 equals 5. So that means you have to distribute this -1 first, which means we have -3x plus 2 equals 5. So that means -3x, well, let's go back. We subtract 2 from both sides. We get -3x equals 3. Now we divide both sides by -3 to get x equals -1. Okay, so now we check our solutions to see if they work. It's important that you check. So we check in our original equation. So we have 7/3 as one possibility. So wherever you see an x in your original equation, you put the number that we're checking. So we're checking 7/3. So 3 times 7/3 minus 2, we want to take the absolute value of that. Notice that the 3's cancel out. So we have the absolute value of 7 minus 2. That's equal to the absolute value of 5. The absolute value of 5 is 5, which is exactly this. So yes, this is a solution. So now we check -1. So the absolute value of 3 times -1 minus 2 is the same thing as the absolute value of -3 minus 2. That's the absolute value of -5. The absolute value of -5 is 5. So again, this checks as well. So our solution set is x equals -1 and 7/3. That's our final answer. Okay? So now we know how to solve absolute value equations as well. Now, the other thing that we want to talk about here is solving linear equations for one variable. Let's solve for the indicated variable. Here, we have P times V, like PV, you know, yes? PV equals N times RT. We want to solve this equation for T. So we want to get T by itself. This one is easier than it looks. So we have PV equals nRT. We want to get T by itself. So we need to divide both sides by N times R. So the N times R's, they cancel on the right, leaving us with PV over N times R equals T. We've isolated our variable. That's the final answer. So we solve for T. Okay? Excellent. Now, let's talk about some applications of linear equations. We want to figure out how can we apply it to real life situations. Let's talk about distance first. Distance has the following formula. You need to know it. D is equal to R times T, where D is the distance, R is your rate, T is your time. Simple interest, I is equal to PRT. I is your interest earned, P is your principal, R is your rate, T is your time. Okay? These formulas you must know. And you must know what the variables represent. Okay? So let's do example 5. Okay, let's do example 5. Jada inherits $10,000, but she invests her inheritance in a global technology mutual fund. At the end of 1 year, her investment is worth $12,800. What has her effective annual rate of return been? So in other words, we want to find out what was her rate. What was her rate? So we're not talking about distance. We're talking about simple interest. So the formula we use is I equals P times R times T. Now let's figure out what we know. We know that her investment is worth $12,800. So I, which is her interest earned, if we know she inherited $10,000 and she invested that, and then her investment after a year was $12,800, that means $12,800 minus $10,000 is the interest that she earned. So I is $2,800. Okay. P is her principal, so that is her $10,000. R, we don't know. T, which is the time, we said at the end of 1 year. So that's her time. So all of that times 1. Okay. Well, this means 2,800 is equal to, because 10,000 R times 1 is 10,000 R. So then we divide both sides by 10,000. To get R is equal to 28%. So the rate was 28%. Okay? Let's do one more example. Two trains are 630 miles apart, heading directly toward each other on parallel tracks. The first train is traveling at 95 miles per hour, and the second train is traveling at 85 miles per hour. How long will it be before, let's finish writing it, before the trains pass each other? So let's finish the question. Okay. How long will it be before the trains pass each other? Okay. So we know D is equal to R times T. So distance is equal to rate times time. Well, we know the distance was 630 miles because they were 630 miles apart from each other. The rate is 95 plus 85. And the time is what we don't know because the question says how long, which means we need to find our time. So now this means 630 equals 95 plus 85 is 180 times T. We now divide both sides by 180 because we want to get T by itself. And so that means T is equal to 3.5, which means our unit, remember, is hours. So T is 3.5 hours. And those are their applications. This is section 2.1, which is linear equations in one variable. Now do your homework.